Okay, in this video I'm going to show you how to construct the Euler line, named after Leonhard Euler, 18th century mathematician. First one we're going to do, first construction is a perpendicular bisector, which cuts a line segment in half at 90 degrees. This is what it looks like. You do the arcs, rule the line, and you have bisected that line segment at 90 degrees. Next is the median. We already know the midpoint from the perpendicular. There it is. Median connects the midpoint of one side to the vertex of the other. All my medians are going to be in blue, and my perpendicular bisectors are going to be in pink. Next up is the altitude. It goes from a vertex perpendicular to the opposite side, not necessarily at the midpoint. We center at the vertex, do my arcs, shorten my radius, do a couple more arcs. From that point of intersection of the arcs, we rule that up to the vertex, and we have our altitude. Let's see, there it is. 90 degrees. All my altitudes will be in yellow. Now we're going to use these three constructions to make our Euler line. Starting with the triangle ABC, I'm going to do the perpendicular bisector of AB first. Center on B, set my radius, do an arc down there, do an arc up there, center on A, do an arc up there, an arc down there, make sure the arcs intersect. And the point of intersection of the arcs we rule up as close as we can. And there is my perpendicular bisector for AB. And there's a 90 degree, and we'll label that midpoint D. It looks like an O, but it's a D. Now we'll do the perpendicular bisector of BC. Do an arc down there, arc up there, center on B, do two more arcs, line up the points of intersection carefully, and rule it. Okay, now there's the perpendicular bisector for that side of the triangle, for BC, and those two equal marks there, congruent marks, just to show that it is the bisector, means cut in half. I'll label that point E, and of course CE is equal to BE because it bisects it, and AD is equal to BD. Okay, and that'll be true for this side of the triangle as well, AC. So let's do the perpendicular bisector for that one. Carefully rule it up. Make sure the radius is a little bit more than halfway. Do a couple arcs from that end point and do a couple arcs from C. Rule it up with a ruler, and they do intersect at one point. That's pretty cool. All three perpendicular bisectors intersect at one point just above D. I'll label that point A, B, C, D. Why not label it F? Okay, and F does have a special name for all the perpendicular bisectors intersecting. It's called the circumcenter. Okay, so where that point F is called the circumcenter. Next up, medians. Let's do the median for each side. Now remember, I have all the midpoints already. So if I rule up AE, carefully, that is the median from A to side BC. There's the first median. Oh, let me label this midpoint over here. I'll label that G. And if I rule up BG, that is another median. That's the median from B to AC. Okay. And the last median is going to be from C to the midpoint over there, which is D. And carefully there. And lo and behold, all three medians intersect at a point as well. Pretty cool. That is pretty amazing in itself right there. We'll call that point H. Lastly, I'm going to do the altitude, but before I do that, H has a special name. It's called the centroid, where all three medians intersect. Next up, the altitude. The altitude is going to, for AB, is going to be from C perpendicular to AB. Now this one's tricky. I center on C, put a couple arcs on that line AB, and now I center on those arcs, shorten the radius a tiny bit so I don't go off the page, and I want intersecting arcs. There they are. So I'll rule a line from C to those intersecting arcs very carefully, and there's my altitude from C to AB. Next, I'll go from A to side BC. What's the altitude there? That looks like a 90 degree angle, so I'm going to extend that side of the triangle just a little bit to help my construction. Center on A, and I want a couple of arcs through that side of the triangle. One right there and the other one right there, which I just extended. Shorten the radius so it doesn't fall off the paper. Two more arcs, and I'll connect the point of intersection of those arcs to A, which is off the page right now. I think I might need a bigger ruler. Yes, I will. Now the altitude here is almost that side of the triangle. Almost. So I'll rule that up and give it a highlight, and there's the altitude from A to BC. One more to go. I want an altitude from B 2AC. Let me stretch this line out a little bit of the triangle. Make sure I extend the line of the triangle, not the altitude. All right, center on B, give 2 arcs through the sides of the triangle, and then center on those arcs, shorten the radius a little bit, intersecting arcs, that point of intersection, connect that to B. And I will get the altitude from B to that other side of the triangle, and that altitude is almost the side of the triangle as well. So when I drew my triangle, it was almost 90 degrees. And what do you know? All 3 altitudes intersect at a point as well. We'll call that point I. Now, here's where it gets special. Point I is called the orthocenter, where all 3 altitudes intersect. Now, Leonard Euler, figured out that all 3 of those points, the circumcenter, centroid, and orthocenter, fall on the same line. Which, if I rule up, I did it pretty close. He called the Euler Line. I don't know if he called it the Euler Line, but that's what we call it now. All 3 of those points fall on the same line. That's the Euler Line. Could have come up with a better name, possibly the circumorthoroid or something like that maybe. The Euler Line is just a boring name for a very cool concept.